Our next speaker, Sarah Petkus, is a kinetic artist and roboticist from Las Vegas. This is her second time speaking at our second super conference, and she's going to be bringing up a demo. She's bringing one of the robots that she's working on. So please welcome to the stage, Sarah Petkus.
Hi, guys. Sweet. And we're looking at what everyone sees. Deal. Okay. Let's set up. All right, everybody still awake? Yeah? You're relaxed? Everyone's settled in? Okay, so I'm not actually doing a demo of this guy right here. My talk, it was called something like Tasting Feet and Mechanical Systems and Behaviors. I'll be demoing those later. I'll be here all night. I've got a whole bag of feet to show you guys and talk about right now, so I don't know, get ready. And I'll put those there. All right, so I kind of decided to do this like today, and I hope I don't regret it later, but I'm gonna start this talk off by doing something a little strange to break the ice. And I'm going to take like this stuff and I'm gonna squeeze a little bit into my hand, and there's a reason why I am doing this, and I will demonstrate it later, but this is more or less just to remind me how absurd this all is and relax me while I'm up here. So I'm going to talk to you guys while holding a fistful of like lube. Yeah? All right, so this is my talk. It's on mechanical behaviors, and it has to do very much with my robot right here, Noodle Feet, who I talked about last year in like great detail. To talk a little bit more about who I am, my name is Sarah Petkus. I have an extensive background in traditional arts. I'm an illustrator, printmaker. At some point while I was in college, though, I started tinkering with electronics. Somebody gave me an Arduino, and I started making actual mechanical things out of garbage, really. Anything that I could get my hands on. I started a blog about 5 years ago where I pretty much documented my entire process going from relative cluelessness to where I am now, and I've done some cool things since along the way, and I've learned a lot. And I'm here now. I'm here to share with you what I've been working on, as well as get feedback. So as I'm walking around here tonight and you get more familiar after I give my talk with these sorts of projects and problems that I'm working on, I would love to hear feedback because all of you guys are brilliant. You have diverse areas of expertise. I have some art background, but I don't know anything. I'm really picking up my knowledge in mechanical engineering, writing code, designing circuits on the fly and as I go. So if anyone has any ideas in regard to stuff, talk to me. I'll be here. Anyhow, moving on. So my talk is called Tasting Feet, Behavioral Quirks, and Mechanical Systems. So what are tasting feet? That's a really strange word, right? Okay, so the tasting feet that I'm going to be talking about are mechanical enclosures for my robot that's on the floor right here. This guy's name is Noodle Feet. He's a character of mine. He has kind of these cylindrical stalks that you can see that are actually right now pool noodles. But since his name is Noodle Feet, I decided that he should actually have some more interesting feet to go with his name. They should actually do things and not just be passive. So let's see. What the heck is Noodle Feet? Last year, when I spoke here at SuperCon, I discussed in great detail who this character was. So as an illustrator, I guess I can skip to this. There we go. I illustrate this comic called Gravity Road, which is about electronics, or it's about robots, electronics, a post-human world, and it's about the machines we leave behind and how they view our art that we created while we were here. And it's about a lot of other stuff too. But one of the characters that's reoccurring is this little crab-like guy who is the Noodle Feet character. And at some point in time, I decided that I wanted to actually create this thing as a physical working entity. And the challenge that I set forth for myself last year was that I had to design the robot, and it needed to not only function and be a quadruped, but it had to maintain the same physique as the character. So it had to look like the thing that I have been drawing for so long. And I had speculated last year, and I can push forward. Oh, there we go. The physique is kind of like a lamb crab. I don't know if you can see him on the floor right here, but he looks like that, more or less. And if you don't believe me, that's him. He's a cute little guy. He's 2 now. So let's see. To recap on last year, I had basically pitched a bunch of different things that I wanted him to do, like behaviorally. And NoodleFeet's primary function is, as a quadruped, to wander around on the ground and locate legs to lean on, and then based on whether or not he recognizes the person who he's leaning on or following, he would engage in some sort of behavior. And by behavior, that could be something like leaning on them, beeping, emoting some sort of act, or I had talked about creating a salivary system so that he could actually excrete fluid on the person who he's leaning on, or root himself to the ground with toes, or any number of other strange behaviors when seeing the person. So, noodle leaning on the leg. The tasting feat, basically, the challenge that I created for myself and have been working on for the past year since I've been here at SuperCon is to basically take as many quirky, strange ideas or behaviors or personality quirks that I want this character to have and actually make them mechanically viable and then jam them into a 4x9-inch cylindrical space. So I've spent my summer more or less iterating different ways of doing 3 particular behaviors, and what I focused on was the act of gripping onto things with small, tiny hook-like toes. So I wanted each foot to have an entire radial array of little burrs that he could kind of just plant himself with. So if you tried to move him and he didn't want you to, he could just be like, no, and then you can't lift him up. I wanted the center of each one of his feet to have a tongue so that if he encountered you and decided to, he could actually lick you. In addition to licking you, he could also salivate on you, or just leave a puddle of juice in his wake as he walked around on the ground. So, anyhow. The first thing that I addressed was the gripping, which was the most mechanical and probably most involved part of the whole design. It would have the most moving parts. And the thing that inspired me to add this feature to this particular robot was actually a probe that I had seen, which was developed by JPL. There's this video floating around of one of their apparati that is part of the Lemur project. And it's basically an asteroid drill that has hundreds of micro barbs that just sort of flare out around a central hub. And a drill goes out the center once it's attached to the surface of the rock with all these micro burrs, and it drills samples and sucks them back in, and then it can release the hooks and then kind of continue wandering with these claws, which was very inspiring to me and very visually exciting. So that was the thing that made me go, oh, okay, well, I'm gonna replicate that using what I have available to me, and I've got a 3D printer and SketchUp, so I was like, all right, ready, go. So last year, I was just mocking up the design of these toes. In SketchUp, I decided to create something that would have radial channels that toe filaments could be forced down and outwards from. And I had no idea how I was actually going to do this, how I was going to actuate it or drive it once I got the mechanism to work. But I started playing around with parts. I printed them out and started messing around with the way that the filament reacted when I pressed back and forth on the tendons to see if I could get them to torque outwards and then grip onto things and then torque back up to release and go back into these sheaths, and how I could go about doing that. And I eventually did come up with something that did work quite well. I created these radial spokes that 2 different filaments would connect to, and I have all of these prototypes along with me in this bag, so I'll whip them out and just kind of spread them out later. You can come up and inspect them if you're interested. But the radial spokes, there's one end of a filament attached to the upper spoke, and then the other filament is attached to the bottom spoke so that like an amount of tweaking and torquing is created with the toe so that it does hook onto things. So if you press down on these rings, it just sort of, it works to actuate, and it does so quite nicely. So once this did mechanically function the way that I wanted it to, and it's spring-loaded, so if you press down, it will go back up, and it'll suck the toes in. I had to figure out how I was going to drive it, and I currently have kind of a variety of weak hobby servo motors at my disposal to use and kind of play around with. So I started from here with just a regular RC servo, and oh no, I totally lied. Look at your slides. Okay, I don't know a whole lot about solenoids, but I started there because it seemed like a poking motion would be the most obvious solution for this. And needless to say, this didn't work. You can see the size of these. It's like they're not very powerful. Whatever I ended up buying, I didn't do enough research, and I just sort of picked something and went with it and learned very quickly that like this wasn't the way to go. If I wanted more power and more poking, then they're going to have to get larger, and then I was going to blow my whole 4-inch diameter footprint that I was trying to like, fit the constraints of. So that went away. And I did go back to the hobby servo motor with a cam and a planetary gear system. So the way that this worked, and it worked pretty well in the beginning, is that I had a planetary gear sitting on top of a cam that once it rotated, the ramp of the cam would press down on some rollers that sat on top of the ring, and as the bump rode on top of the rollers, it would press the entire thing down, thus actuating it. But since it was 3D printed, there was quite a bit of chafing. There was a lot of friction. So I eliminated as much as I could, but it still was very taxing on the motors. And though it did work, it was a loud, like, not ideal solution to the problem that I was trying to solve. And more pictures of the toe mechanism. TTT. So around this time that I figured out how to drive the toe mechanism, I went on a field trip to JPL, and I saw the thing that inspired the toes in real life, in person, and I got toe envy, and I saw all the little barbs and got really excited, and it was just this amazing shape that I know just reinforced in my mind that I wanted all these radial toes to just sort of poke out and it to be kind of intimidating and scary, and I wanted Noodle to assert his dominance and just sort of, I don't know, have this presence about him when he put all of his toes out. So if I compare these, like, I'm still holding my hand of lube here. If you compare them, that's pretty sparse. I think I started with 8, like all the way around just to get it going. And once I saw that, I was like, no, I need to at least like double my toe output. So I doubled the number of toes. That's a toe birthday cake. I don't know. That just looks delicious. It's way more exciting. So that is, what did I say, 16 toes? So I had to get rid of the use of hardware up at the top. So when I mounted my toe filaments to the rings that actuate them, I actually threaded some rubber hose through there, which isn't great for having to fix anything if it breaks, but for now it's working, and it makes the whole thing a lot lighter. There is a lot more friction because there's a lot more things making contact with other things, and it's a lot more chafy, but it still works. And, oh yeah, I'm gonna move on to licking. Okay, so with the toe cake in its like final form and everything looking fantastic and red and pretty, I decided that, okay, now I have the most complex, like mechanically complex portion of his foot taken care of. I've got lube all over my keyboard. Crap, okay. This was a bad idea, but I don't know. I'll talk about it later, I'm sure, tonight. Anyhow, so with the most complex mechanical portion taken care of, I had to add the element of licking back into the design, and I knew that I wanted Noodle to have a darting tongue that poked in and out of the center of his foot, and I figured it should be silicone, probably brush-like, I knew I'd seen these basters like floating around, like, you know, those like William and Sonoma or whatever, yeah, you fill the reservoir up with like juice and then you screw on the silicone brush thing and you squeeze it and it poops out your barbecue sauce onto your whatever you're basting. They make a type in China that just has one pore and it actually has threading on the inside. Looks kind of like this. So I could pop the bladder of this brush off and then use the brush as a tongue. And since it has one pore in the center, I can easily just stick some rubber hose in there to drain whatever fluid he ends up excreting eventually. So this was the plan at the time. So originally I thought I was going to make this thing spring-loaded, kind of like the toes were. I even tried using a rack and pinion system to convert the rotational motion into linear motion, but that didn't work very well because I couldn't get like an equal force, like distribute the force equally down on the plunger bit to make it go straight up and down. It just kind of would torque and then bind and whatever. It had that sort of constraint. I probably could have messed with this for a really long time and eventually got it to work in the space that I had available to me, but it was a lot easier to, that's the rack and pinion. It was a lot easier to kind of just scrap this once I saw that it didn't work and then make a parallel linkage, which I've built a lot of Delta robots in the past. I don't know why this didn't occur to me like right off the bat, but yeah, this worked a lot easier and it took up way less space and there's like no chafing or grinding. It just sort of like fluidly without touching anything. As the servo motor like actuates, it just sort of swings the tongue like the 5 or 6 millimeters that it needs to poke out the bottom and actually make contact with whatever he's licking, which is usually the ground anyway. So it was easy to take those two systems and fit them into one space. The tongue fit down the center of the toes, everything was more or less happy, and I was able to create my first actual tasting foot mechanism with just the two systems, and it looks something like this. It's kind of like a bomb, but it's a cute white bomb. And I mounted each of the systems to a disc that fit radially inside of the frame. So the up and down pieces are just holding basically slices, like little pancake slices that have all of the working parts mounted to them. And they can kind of, like if I need to adjust any of the designs relative to each other, all I have to do is really move those up and down without having to really change the overall meat of the design. So onto the drooling. So I did say that my robot was supposed to leak, and part of this just stemmed from lots of conversations, probably like drunken talks late at night of how interesting it would be if this character could actually walk up to you and lean on you and not only like just sort of pause there and be uncomfortable, but also once it walked away, leave a wet spot on your jeans or something. Or just leave a puddle in its wake. Either way, drooling robots. It's an interesting like notion. I mean, I don't know if any of you have also met robots that excrete fluids or drool like specifically, but I think that's an interesting, charming idea. So he needed to do this. Originally, I had planned on going with the whole central design and like sticking with everything kind of just going up the center of the foot. And I wanted to use a feeding syringe with a stepper motor. So once the stepper spun, it would be able to very discreetly allow him to push out a very, finite amount of fluid, like down to like exact like decimals of cc's, which was appealing at first. But it did take up a lot of space, which I didn't have, and I was again blowing my 4 by 9 inch footprint that I needed to stay inside of for this build. So I kind of went back to another element of the robot that like feeds itself back into the like character behaviors, personality quirks, like developing the actual illustrated character and bringing more elements of him into the robot. And one of the things that I always associated the robot as doing is making this sort of like wet, like suction sound as his voice, in addition to beeping. So this was like kind of like a noise. You know what I'm talking about? Like when you're drinking a Slurpee and you get to the bottom and there's not a lot left, but you keep doing it anyway. It makes that noise, and it's in your head right now, right? Okay. So, and this is why I have a handful of lube. and I'm gonna wipe it off soon, so I'm really excited because this was kind of a bad idea, but I'm sure none of you have done this either on stage while giving a talk, so I don't know. All right, so this is, thank you. I'll wipe it on his blanket. Terrible mother. All right, so this is the bladder that came with the tongues that I ordered from China. I got to reuse these because if I take this guy and I push this onto my hand, get it like looby, it will make that exact suction noise like I came to find. And I actually like spent a day like figuring out ways to do this. So this was a whole like R&D, like, I don't know, weekend, I guess. I don't know what that sounds like to you guys, but you're giggling, so I think you get it. Okay, so that's his happy noise, all right? Which I think is appropriate. Okay, I'm done. All right, so I needed to figure out a way, now that I knew how to make this sound with something other than a straw or my mouth, I needed to figure out a way to mechanically make this action and force that to happen when I wanted, right? So the very last mechanism or behavioral system that I had to develop was the squeezer or the pincher for this bladder. So there were two things that immediately seemed obvious to do this, to actually pull off squeezing this thing. One of them was like a forcep or like a scissoring pinching motion, like two pieces that are on a hinge that are kind of forced inwards on each other and pinch either side equally on either side of the bladder. Yeah, obvious, right? Part of what I do in designing these mechanical systems is I go for the most probably theatrical or visually appealing approach to the problem versus the most probably like technically viable one, because it's art, right? It should be weird and interesting and make you go, I wouldn't have thought of doing it that way. So I decided to go with an aperture approach. So I made a 3D printed sphincter and I put it around this bladder and drove it with a planetary gear. And I found that it doesn't work if you kind of squeeze it from all angles at once, because the thing has nowhere to go. The bladder can't compress in any direction really, and it doesn't work as good. But if I only kept two of the leaves of the aperture in on either side, it basically, while still looking like an aperture, did the pinching motion where it would kind of squeeze from either direction. And it actually worked. Like, I was able to replicate the suck sound with a servo motor, a planetary gear, and a juice hole, or like a whatever, aperture, iris. So I have all of these here with me. The only problem now is I have the mechanism and it works, and the module does exactly what it's supposed to, but the cheap motor is slightly louder than the juicing noise it's making. So I either need to get more silent motors, or I thought it would be kind of audacious to actually get a microphone like I just did and aim it at the sound being made so that it just gets amplified through a speaker. So my little robot can just walk around and then just project really loud and obnoxiously this sound. I mean, I could go that route too, and I might, but that's where I'm at currently. So yes, big kid feet. I have 4 of them. I built these things. I jammed all of the systems into one space. The only one that isn't added into these as of yet is the juicing, module, I guess. The juicing module will go into that space up at the top. I have to figure out a way to kind of leverage the area that I have left, so it's gonna take another spin of redesigning everything to just mash them all in, but the other 2 are there. I've got the towing and the licking and the rest of his like big kid leg put together, and he's coming along. Like, he's growing up, he's going through puberty, right? So To drive these boards, I made a dedicated board specifically for his big kid feet that you can see there on the side that says grip, lick, juice, ox. So it drives those functions. This is his brain bean. I believe in making beautiful boards too, so I always try to make them like interesting, like the sort of thing you would find in a robot that's a character or a human if we had circuit boards that ran us, I don't know. Like we have organs and they're all amorphous, so I don't know. My kid will have the same sort of thing going on. And his brain board, the one that's actually in his head, looks like a little like piece of like a brain if it were a brick of ramen, which I think is also appropriate. And then I'm also making him stronger. So he has metal legs now. I'm slowly going through and I'm replacing all of his plastic parts now that they're prototyped with aluminum ones. So I'm learning how to machine things, which is great because, again, like that's not part of my repertoire, or it hasn't been up until now. He's getting stronger, and that also means that he's getting closer to actually walking. And again, like this is another year, I'm bringing him back, and I feel like sort of a heel because he still can't walk reliably yet. And it's probably partially due to how he actually mechanically moves, the fact that he's very top heavy, but it's also because 3D printed parts are very brittle and they break and they sway and they give. And before Noodle can actually lean on you and leak on you, he will need to have more metal. So puberty, right? So improvements, yes, I just spoke of those. He's going to get more metal parts. I'm going to continue shrinking down all the systems in these feet to make them lighter, more optimized, and more viable for a creature that actually is going to have to lift them up and move them around. So they're not going to look like this in another year, I'm sure, but they are a place to start, and they work, and I've learned a lot. If anyone has any feedback, like you know licking, you know your like grappling hook toes, or you've done something similar, like talk to me. Like I will whip out my Wacom and my computer and we can draw together. Seriously, I would love that because I need input. And oh yes, so now that I have all these behaviors, I'm developing behavioral routines. And I think I mentioned this in the beginning, but now that he has things that he can do, once I get the face recognition working, if he sees somebody that he has seen more than once and remembers the face or the color or the situation or whatever I can do with that, he will respond by executing any of these functions. And that's where I'm headed next. So deep into the realm of code writing, which I love. That's a joke. But yeah, I think that's the end of my talk. And I don't know, like, I'm going to step off the stage now. But thank you for listening.